Here we have a geometry problem and two column proof. Okay, let's go to the question. Given AD is congruent to AE and angle B is congruent to angle C, and we have to prove the line segment BE is congruent to the line segment CD. Okay, so since it's a two column proof, first let me write the required stuff. Here I have written two columns. In the first column I am going to take statements, and in the second column I am going to take reasons. Okay, now first let me consider the given information, that is AD, line segment AD is congruent to AE. Let me write the stuff over here. It's congruent to AE. So we have to say the reason that is given. It's given in the question itself. The second one is angle B is congruent to angle C. So that is also given in the question itself. Okay, now let me mark these two stuff on the picture over here. So AD is congruent to AE, and angle measure B is congruent to angle measure C over here. Okay, now let me consider the two triangles over here. So the first triangle is that is BAE, and also let me consider the second triangle, that is CAD. Okay, now in the first triangle BAE, I consider the angle measure A over here. Now in the second triangle CAD also I consider the same angle measure over here. So this is a common angle for both the triangles. Okay, let me write the stuff over here. That is angle A is congruent to angle A. So actually this is reflexive property. Let me write the stuff over here. Reflexive property. Actually, the reflexive property says any angle measure is congruent to itself, and also any side is congruent to itself. So by reflexive property, angle measure A is congruent to itself. That is, angle measure A is congruent to angle measure A. Already we know that angle measure B in the first triangle is congruent to angle measure C in the second triangle, and A is a common angle for both the triangles, and the side AE in the first triangle BAE is congruent to the side AD in the second triangle CAD. Okay, now let's consider the components of the first triangle in order. That is angle measure B, angle measure A, and the non-included side AE. Now let me consider the same stuff in the second triangle as well. Angle measure C, angle measure A, and the non-included side AD. Clearly, the two angles and a non-included side of the first triangle BAE are congruent to the two angles and a non-included side of the second triangle CAD. Whenever two angles and a non-included side of one triangle are congruent to two angles and a non-included side of another triangle, then the two triangles are said to be congruent. So here by angle side congruence postulate, the two triangles are the triangle BAE and the triangle CAD are congruent. Okay, now let me write the vertices in order. Okay, first let me take the vertex B in the first triangle. The corresponding vertex in the second triangle is C. So let me write the vertex of B, and here we have C. And now let me take the common vertex A for both the triangles. Let me write it over here and here. And the third vertex in the triangle BAE is clearly it's E. And the third vertex for the second triangle is that is D. So these two triangles are congruent. So here by angle side congruence postulate. Since two triangles, that is triangle BAE and triangle CAD are congruent, their corresponding paths also must be congruent. So we conclude this by CP-CTC theorem. CP-CTC theorem, that is corresponding paths of congruent triangles are congruent. Okay, now let me consider a particular part in the first triangle, triangle BAE. So that is the side of the triangle BE, which is covered by the first alphabet over here, the third alphabet over here. So let me take the side BE from the first triangle, and it must be congruent to its corresponding part in the second triangle. So which side is congruent corresponding to this side B in the first triangle? So here, how did I get the side B? I took the first letter and third letter. To get the corresponding side in the second triangle, we have to consider the letters at the same position. That is the letter of the first position, the letter of the third position, that is CD. So the side B of the first triangle and the side CD of the second triangle are corresponding sides. So these two sides must be congruent by CP-CTC theorem. That is, the corresponding paths of congruent triangles are congruent. Okay, using the given information, I have proved the line segment BE and the line segment CD are congruent.